Today we're going to talk about direct and inverse variation. So direct variation is in the form of y equals kx. This means that y varies directly with x. So whatever x does, y is going to change by whatever k amount, where k is called a constant of proportionality. So it's the proportion that is multiplied by x, and that tells you how much y is going to change. So that's why y varies directly with x. Also, if you think all the way back to probably 7th or 8th grade when you talked about independent and dependent events, x is always the independent one. So y varies directly with x, so y is dependent directly with whatever x does. And then if we have inverse variation, that is in the form of y equals k divided by x. So that's where y varies inversely with x. So again, y of course is still our dependent variable. So it's going to change depending on how x changes, but in the opposite direction. So if x goes down, y is going to go up. And if x goes up, then y is going to go down. And again, we're depending on the constant proportionality k here to determine that. So let's say we have an example where y varies directly with x. And x equals 9 when y equals 6. So what we want to do is find x when y is 15. So in order to find out what x is when y is 15, I need to know what the constant proportionality is first. I need to know what factors changing x and y. So to set this up, they give me x and y first. So if they give me x and y, I guess you can't see that. If they give me x and y, then we need to find k. So first thing we're going to do is find k. Again, I know we're varying directly, so I'm going to use this first formula up here, y equals kx. And then I'm just going to plug in what I have. So 6 equals k times 9, because x is 9. Well, to get k by itself, I have to divide by 9 on both sides, because division is the inverse of multiplication. And so then that simplifies to tell us that k is 2/3. Well, now that I know k, I need to find x when y is 15. So now I know y and I know k, so I'm going to plug those back in to find x. Now I find x. Again, we're still varying directly, so I'm still going to use this formula here, y equals kx. They told me what y is, it's 15. K I know is 2/3. I just need to know what x is. Again, I can divide by 2/3 here. Now when I divide by a fraction, I always have to make sure I use my parentheses. So my calculator here, I have 15 divided by 2/3. So notice how the 2/3 is in the parentheses there. And change that back to a fraction. So I get 45 halves is what x equals. And that's it. Let's do a story problem. So we have a problem here where the volume of a gas in a container at a constant temperature varies inversely. So the volume varies inversely as the pressure. Those are the keywords we're looking at. So if the volume is 32 cubic centimeters at a pressure of 8 pounds, we need to find the pressure when the volume is 60 centimeters cubed. So I'm going to set this up. I know it varies inversely, so I'm going to use y equals k over x, because it varies inversely. Now my y in this case is going to be the volume, because the volume is what varies inversely as the pressure. So my pressure is what's changing, and because of that change in pressure, the volume changes as well. So y is my volume, because the volume varies inversely as the pressure. So if I want to rewrite this, I can change that to a v, and then k, and so x will become p. Well, now I know the volume is at 32 when we have a pressure of 8 pounds. So the first thing I have to do, of course, is find k. So I'm going to plug in for my volume. So 32 equals K over P, which is 8. To get rid of that 8, we need to multiply because it's being divided. So the inverse of that is multiplication. So that makes a 1. That goes away. Then 8 times 32 gives me 256. So 256 is K. Well, now they told us to find the pressure when the volume is 60 centimeters cubed. So again, using the same formula, because it's still varying inversely, now I'm just going to plug in for K and V while looking for P, the pressure. So V is 60, K is 256 over P. In order to get P by itself, I have to multiply on both sides, of course. So this P on this side goes away. So I have 60P equals 256. And now I'll divide by 60. So 256 divided by 60. P equals 64 over 15 is our answer. So those are a couple examples of how to figure out direct and inverse variation when we have a word problem. The other type that we need to look at is if we're looking at a table. Now when we use a table, we use the exact same formulas, we just use them in a different way. So let's say we have a table that looks like this. 108. So my table looks like this. Now, when we look at this table, we need to determine if it varies directly or inversely. Now, if it varies directly, then we know that we have this formula, y equals kx. Now, when we looking at this table though, we have x and y. So what I'm going to be looking for is k. So in order to find k, I can rewrite this as a literal equation. If you guys remember talking about that, I can rewrite this to get k by itself. So to get k by itself, I'm just going to divide by x on both sides. So y over x equals k. So if it varies directly, then this is what k would be if I got k by itself. That means if it varies inversely, remember y equals k over x when it varies inversely. So to get k by itself, I have to multiply by x on both sides. So xy equals k, and that's going to be the constant proportionality when it varies inversely. Sorry, that's a little mess right there. Okay, so k equals xy. So what I'm going to do with this table is check if it varies. Sorry, that's the bell. I'm going to check if it varies directly by taking y divided by x. So I'm going to take y divided by x. So that's 108 divided by 1. And then 54 divided by 2. Well, 108 divided by 1 is just 108. And 54 divided by 2 is 27. Those are not the same at all. So because those are not the same, I know this does not vary directly. So what I need to do next is check if it varies inversely, and I can do that by multiplying x and y. And if I multiply them and get the same constant proportionality for the whole thing, then it will vary inversely. So if we try that, that means I'll take 108 times 1, 54 times 2, 3 times 36, 108 times 1 is 108, 54 times 2 is 108, 3 times 36 is also 108, so I'm going to keep going to test the rest of the table. We have 9 times 12, and then 12 times 9, and those are both 108 as well. So because I get 108 for the constant proportionality for all the numbers in my table, then this varies inversely. And that's how you can tell direct and inverse variation. I'm sorry about all the interruptions.